Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So within the first module, we are on the third topic, that is the compute stack. And as we have already seen, the compute stack is a view of the computer system where we say that the computer is composed of a stack of layers, right? And we have already seen what are these layers. So in the previous few videos, we have looked at the computer hardware, the bottommost layer in the compute stack. After that, we looked at the operating system, which builds upon the hardware and is responsible for managing it, right? So now we are going to look at the next layer, that is the programming libraries. So programming libraries is a layer of software that further simplifies the interface that is provided by the operating system. So now let us look at programming libraries in more detail in this video. Let's get started. So this is the compute stack, and as you can see here we have the programming libraries. So the programming library is a layer of software that sits between the user applications and the operating system. So now as you can see, there are two layers of software between the user applications and the computer hardware. Ideally, the user application should run directly on the computer hardware, but as we know, this hardware interface is too complex to program, right? So that is why we had the operating system. So one of the fundamental responsibilities of the OS was to simplify this hardware interface. Although this system call interface is much simpler than the hardware interface, but it is still too complex and we need further simplification. So that is why we have the programming libraries. So this is a layer of software that further simplifies the system call interface, right? And this programming interface is what the application developers use to write the user application. So this is the first point, right? So user applications are written over the APIs exposed by the standard programming libraries instead of the system call interface. So this is the first motivation behind having the programming libraries, that is to have a much simpler interface that is easier to write programs over. So now let us see how the programming libraries work and how do they simplify the system call interface. So now let us understand what do these programming libraries contain. So if you have written user applications, then you know that there are certain operations that are often required by the application developer. Some common examples are standard input output, file handling operations, string manipulations, and some mathematical functions. So these are examples of operations that are frequently required by the application developer when they're writing the user applications. So now what the high level languages like C, C++, Java, Python do, they take all these operations that would often be required by the application developer and implement it in the form of a library. So now as an application developer, you don't have to re-implement these operations again and again every time you're writing your code. So what you can do, you can use the APIs that is exposed by these programming libraries into your application. So the idea is to not reinvent the wheel again and again, right? So by using this programming interface, by using this set of pre-written code that has been provided by the programming libraries, your job as an application developer becomes much more easier. So now we'll see how can we use this programming libraries in our code and how does this programming interface looks like. So now let us understand how does the programming interface of these libraries looks like. So basically what the programming libraries does is that they take all the common operations that would be frequently required by the application developer and implement them as a set of routines or functions. And these functions are exposed via an API. So what is an API? So API stands for application programming interface, right? And it is a collection of function signatures. So function signatures or function declarations are a description of what the function does as well as the inputs and outputs. So for every function, the parameters of that function, the type of those parameters, the return value, the type of the return value, everything is properly defined. So you can think of the function signature as a black box for which the inputs and outputs have been properly defined. So when you talk of a black box, you just have to give the inputs and in the format that it is expecting, and then you will get the output that it has advertised. So this is how the function signature works. So now the user application writers or the application developers only need to follow this API, right? They have to provide the inputs in the proper format and they will get the output. They don't need to know how does the function is implemented inside the library code. So this is how an API works. You just have to obey the function signatures and you will get your work done. You don't need to know what it is doing inside. So any software, any piece of software, its interface can be thought of as an API, right? Not only for the programming libraries but also for the operating system. So this system call interface is also an API of system calls, right? For programming libraries, this API is a set of implemented routines that the application developers can use. So this is how an API works. Let us see some examples and see how APIs look like. So this is the mat.h API from the C language, and it has all the mathematical functions that are often required by the developer. So some of the examples are trigonometric functions, hyperbolic functions, exponential and logarithmic, rounding and remainder functions. So some of the examples, right? So let's see some function signatures. So as you can see, this is the sine function, and it is taking one parameter with double type, and it will return the value of sine x in double type again. So you can see there are several function signatures, the name of the functions, the description of what the function is doing, the parameters, the type of the parameters, and the return type is properly defined. So this is how function signatures looks like, and an API, as I said, is a collection of such function signatures. So let us take one more example. The next example is the string package API from Java language. So it has all string manipulation functions. So some examples are length function. So this function will return the length of the string. Then there is substring function. So it basically takes the first index and the last index, and it will return everything between that index, right? So the return type is string. And let's take another example. This contains function basically checks whether a string contains a substring or not, and its return type is boolean. So you can see there are several functions which are often required for string manipulation, and the type of parameters and the return type has been carefully defined. So this is a string package API in Java. So now that we have an understanding of how the programming interface looks like, let us see how can we use this interface in our application. So in order to use this interface, we have to import the standard library into the application code. So let us see some examples of how can we do that. So here are three code examples from common programming languages like C, Java, and Python. And at the top of every code, there is a section where we have imported the standard library. And the way to import the library differs from language to language. So in C, we include header files. In Java, we import packages. And in Python, we import modules. So although the method to import the library is different in all the languages, but we are doing the same thing here, right? Just the mechanism is different. So if you see this section, there are some common header files for common functionalities like standard input output, string operations, math operations, time operations, right? So, and the user has directly used the functions that have been defined in these header files. So for example, string.h has been borrowed, and string operations like string copy, string concatenation has been directly used by the application developer. So they don't need to define these functions on their own now. They can just reuse the code that is part of the string.h library. Similarly, for math.h, this square root function has been borrowed. From this time.h, this local time and time function has been borrowed. So this is how you can import the standard library and use the functions in that library in your application code. And as you can see, there are some common modules across all languages, right? So mat.h here we see for C, and in Python we have the equivalent module of math. So import math module is the equivalent for mat.h header file. Similarly, time.h is for time functions, and the equivalent of that is this date time module in Python. So all the common operations that would often be required by the developer are included by all programming languages in the standard library. So this is how we can import the standard library into our application code. So now we have understood how does the programming interface of these libraries looks like, and how can we import these programming libraries into our user application. So now let us understand how does the code flow goes. So let us say you have written an application and you have used some programming library. So what will happen when you compile your user application, the code that is associated with that API. So you would have used some API, right? So the code that is associated with that API, which is part of the programming library, also gets compiled and linked with the executable binary that is being generated for the user application. So now your executable not only has the code for your user application, but also the code that was written in the programming library. So it has been linked with the executable. And when the program is executing and the control flow reaches that API call, then the control will be transferred into the programming library. So this is how the code flow looks like when you import any standard library into your application code. So after the code flow execution is transferred from the user application to the programming libraries, somewhere in the library code there will be a system call. And when that system call is made, then the control is transferred to the operating system, right? Since the user applications are not written generally over the system call interface, so system calls won't be part of the application. Instead, they will be hidden inside the programming library, right? And when the control reaches the operating system, there in the system call routine is the actual logic, because as we know, it's only the operating system that runs on bare metal. So the hardware interface only the operating system can access. So this is where within the system calls the actual logic or the actual work gets done. So now we have understood how the programming libraries work. So these libraries are actually shipped as part of the language runtime environment. And what is this language runtime environment? So basically every programming language provides a set of tools which the application developer can use for writing programs as well as execute it. So for example, while you're writing your program, you have to you want to use some pre-written code, so you can import the library. And let's say while writing you have some errors, then for debugging your program there is a tool called debugger in the environment. And once you have written your code and you want to execute it, first of all you have to compile into executable code. So for that also there is a set of tools such as compiler, linker, interpreter. So all of these are provided as part of the language runtime environment. So it is a set of tools that enables the application developer from writing program to executing it. So the library is also one of that tool. So now that we have understood how the programming libraries work, we'll take a working example and trace through how the execution proceeds in the compute stack. So this is a simple Python code, and all it is trying to do, it is taking a file path and it is opening the file and checking whether the open operation was successful or not, right? So this is how the library function call looks like. So this is the open function. It takes two parameters. The first is the file path and the second is the reading mode. So here we are trying to open a file that is located at /temp/foo.txt in reading mode. And when this open call succeeds, it will return a file object. We can use this file object to read data from the file. So this is the compute stack, and let us trace the execution of this code through the different layers of the compute stack. So I'm assuming this code has been written in Python. This library is the Python library, and this is the Linux operating system. So the execution starts with the application. So somewhere within the application code, there is a library function call to open a file, right? So we have already seen this open call, and when this call is made, the control will be transferred to the Python library. And as we have already discussed, somewhere in the library, there will be a system call to open a file. So I'm assuming that the system call to open a file on Linux is named as Linux_syscall_open, right? It's a hypothetical name that I'm using. And when this system call is made, the control finally comes to the operating system. And within the Linux operating system, this is where the actual logic of opening a file will be defined within the system call, right? Since the file is an abstraction that is provided by the OS, any kind of operation will be done by the OS itself. So this is where the core logic is, and after the system call succeeds, the value will be returned to the library, and then the library will return it to the application code. So you see how the execution of code first proceeds from the application till the operating system, and after the computation is done, it goes upwards, right? So this was a simple example to give you an idea of how the execution of code happens through the compute stack. So let us take a more complicated example to get a better understanding. So now we'll take a slightly more complicated example. Here we have three different user applications. It's just that they are written in three different languages. One is in C, one is in Java, and the last one is in Python. So all these three code snippets are doing the same thing, that is opening a file. Only thing is that they are written in different languages, right? So now what we will do, we'll see how these three applications are executed, and how does the code flow look like when we have three different programming libraries in the same computer system. So this is how the code flow looked like when we had a simple example of one programming library. So this code flow will become more complicated now that we have three different libraries. So this is the computer hardware, and on top of that we have the Linux operating system installed, and on this we have three different programming libraries. One is the C, other one is Java, and finally we have Python. And on top of each library we have the user application. So here we have three different user applications, all of them trying to open a file. So within each application there will be a library function call to open a file, but it will be in that respective programming language. So this one is in C, this one is in Java, and this one is in Python. So when this library function call is executed, the control is transferred to the respective programming library, and within the programming library there will be a system call, right? So now since we have only one operating system, although we have three different programming libraries, but all of them are running on the same operating system, which is the Linux operating system. So each of them will finally converge to this Linux syscall open, which we have already seen. So this is the system call routine to open a file on Linux. So this is how the code flow proceeds. Although there are different libraries and different applications, the code will eventually converge to the operating system's system call. So let us make this example slightly more complicated. So here we are assuming that on the same computer hardware, we have two different operating systems installed. One is the Linux and the other is the Windows. So although both Linux and Windows operating system provide the abstraction of a file, but the way in which this abstraction of file will be implemented would vary between Linux and Windows, right? And as we know, each operating system has its own unique system call interface. So the system call that needs to be invoked to open a file on Linux would be different from that on Windows. So here we have Linux underscore syscall underscore open, and here we have Windows underscore syscall under open. So let us now see how this situation is handled in the programming library. So let us see how the programming libraries handle this situation of multiple operating systems. So basically the programming language, what they do for every operating system that they support, they include the system calls for that operating system in their code, right? So as we can see, all these languages, C, Java, and Python are supported both on Linux as well as Windows. So they include the system calls for each of the operating system in their code base. So now when your application starts running and the library function call is made, so the control is transferred into the library, and the library checks on which operating system it is currently running upon. So if it is running on Linux, then the code flow will be routed to the Linux system call, and similarly if it is running on Windows, the library will invoke the appropriate Windows system call routine. So this is how the library handles the situation when we have multiple operating systems. So now we'll look at some of the benefits that we as application developers have when we are using the programming interface of these libraries. The first one is that the library APIs are much more cleaner and simpler to use as compared with the system call interface. So although the system call interface is much simpler than the actual hardware interface, it still has some complexities, right? So when we'll study the system call interface in detail in the next module, we'll see some of those. But for a brief idea, basically the system call interface is tightly coupled with the hardware. And when you're making a system call, the parameters that you have to give to the system call have to be placed in the architecture specific registers, and these registers are very hardware specific. So as the hardware changes, your system call will change. And not only that, you have to make the system calls in assembly code, because that is where you can place the values in registers. So this is how they are still complex to use. And now instead of using that, we can use the APIs that are exported by these library functions. They look very much like normal functions, right? So that is why the library APIs are very easy to use as compared with the system call interface. So this is one of the major upside of using the programming interface compared to the system call interface. So the next major benefit of using the programming interface is that it helps us to write portable code. So a code is portable when the same code runs on different platforms without making any changes. So we just saw an example where we had two different operating systems. So had we written our code at this level, the system call interface level, then if we had written it for the Linux operating system, then it won't run for the Windows. Similarly, if we had written it for Windows, then this Windows system call won't run on this Linux OS. And if we wanted to run on both the operating systems, then we have to ourselves handle the logic of routing the or invoking the appropriate system call. But this now has been captured in the programming library, and we can just use the API exposed by the library, and the library takes care of routing the system call depending on the platform. So library basically abstracts out the different system call interfaces and provides us with one unique interface that we can follow. If we obey that interface, then our code is guaranteed to run on all the platforms that the library is supported on. So this is how the library enables us to write code which is portable. So the final benefit that I want to talk about is that now, since we are using the programming interface, we have a wide variety of choices in terms of programming languages. So as we just saw, we can do the same thing in different languages, right? So now we can choose whichever language that we want, and each programming language has its own pros and cons and provides a set of features that we can choose depending on our use case. So for example, C is very fast. When it comes to system programming, C is the preferred choice, but C has some memory management issues that can often lead to errors. So if you talk about Java, then these memory management issues are not in Java because there is automatic memory garbage collection, right? So memory management is done for you, but Java is very verbose. So let's talk about Python. Python, the same thing you can do in less number of lines. So it is less verbose compared to Java, but again, it is very slow because the Python is an interpreted language, so it cannot be used for system programming. So as you can see, different programming languages offer different features, and depending on what you want, we can choose from one of them. So guys, this was it for this video. In this video, we discussed what are programming libraries, what does their interface look like, how can we use them, how do the libraries work, and finally some of the benefits of using this programming interface. So this was it for this video. Thank you very much for watching, and I'll see you in the next video. Thank you.